Okay, let's give this a shot. Okay, good morning, ladies and gentlemen. And it's a pleasure to be here, and thank you very much for welcoming me to Canada's first low-carbon smart mobility conference presented by QTRIC. As USIPA introduced me, Kirk Burkar, I have the privilege of serving as the Vice President of All Engineering Services for New Flyer. I've been with New Flyer now almost 10 years, and previous to that, I was with General Motors for 19 years. And believe it or not, I think I'm almost embarrassed to say, I actually started with leaded fuel calibrations, but I'm not that old, export markets. So I started with leaded fuel, but as my career grew, I became more and more involved with alternative fuels and alternative energies, and finished working with the Chevy Volt and several different hybrid platforms. So that was a great experience. However, my time with New Flyer has been fantastic, and what always led me to New Flyer was their innovation over time. So as Paul prefaced just a few minutes ago, it's clear we're amid a mobility paradigm shift where the speed of change is second only to the demand for change. As you know, New Flyer has manufactured heavy-duty transit buses for more than 90 years and is North America's largest transit bus manufacturer. What you may not know is our first electric trolley was delivered in 1968. The industry's first diesel-electric bus was delivered by ourselves in 1988. And some of our early fuel cell electric buses go back as far as 1993. So we do have an electric bus history to be proud of, with over 7,300 buses on the road with electric motors, batteries, and high voltage systems, and 1,600 of those are zero emission. Our first battery electric bus was in 2012, trialed right here in Winnipeg, and by 2017 we had introduced our next gen electric bus, the Excelsior Charge. So it's very clear. Well, I'll have to keep a close eye on that. Okay, it's very clear we're in a mobility paradigm shift, but we've always led our industry with innovation and technology, and if you rewind to 2010, would we have ever thought we'd become a leading provider of mobility solutions? Would we have anticipated developing and delivering buses, technology, as well as infrastructure? I'd like to think we were technical visionaries at the time, but the honest answer is likely not. We didn't even use the term mobility in 2010. Uber wasn't quite 1 year old, and most of us hadn't even heard of it. That was only 9 years ago, and I know where I was at that time, on the shop floor launching the Excelsior. For us, a new bus, better by design, and intended to be suitable for a wide range of propulsion systems, including battery electric, there we go, there's a delay. Take note, there's a delay. Okay, full battery electric, fuel cell electric, and trolley electric, also known as in-motion charging. Excelsior, now almost 10 years old, a proven reliable platform with the most Altoona tests of any OEM platform and over 1 billion miles in service. Excelsior, familiar to many of you in this room today, is the focal point of a very broad portfolio of zero-emission and low-carbon propulsion offerings. This wasn't a simple evolution of a bus, a platform, or a propulsion technology at all. But as you're aware, both locally and internationally, the driving forces that continue to impact our business aren't really related to the vehicle or vehicle technology. Rather, it was the demand for sustainable mobility in growing cities, as Paul spoke to. Rapid urbanization here and globally is real, and it is a problem. More and more communities will reach megacity status with greater than 10 million inhabitants, and as a result, traffic congestion and pollution are significant. City leaders and communities alike are calling for better solutions to move safely and sustainably through the places they call home. With the drastic impact of climate change becoming increasingly visible and destructive, cities are demanding action, and rightly so, for industry leaders and transit stakeholders to champion urban solutions to mitigate climate change. As a whole, we're experiencing a profound movement to more livable cities, again, as Paul touched upon, and as we look forward to 2020 and beyond, there's still a lot of work to do to make this happen, despite all we've achieved since 2010, alongside industry leaders like QTRIC. One example we're very proud of, in addition to some of what Paul touched on, was the opening of our Vehicle Innovation Center in 2017 for the purpose of education and collaboration, with a strong focus on the facts and the future of the transit industry and the mobility paradigm. There we go. Again, as I said, there's still a lot of work to do to navigate through the mobility paradigm to ensure the livable city can happen in our lifetime. Well, I could spend hours reviewing the technical capabilities and advancements of our zero-emission buses. I think the most important element to focus on is not the buses, but rather the technology and the infrastructure, the enablers. Why? We can design and deliver industry-leading buses like our Excelsior Charge or the Charge H2 as seen here, but that's no longer enough. In 2010, I'm not sure we could have appreciated the magnitude of consideration infrastructure needed or would need. So it's hard to imagine today that we have almost 100 depot chargers and en route chargers in process or fully deployed or will have by the end of year, and that we, as an industry, have standards that allow for full interoperability of all OEMs. Again, both significant and unimaginable back in 2010. However, what we did have enough insight to initiate back in 2011 was our Connect telematics system. Why? Because data helps you make better decisions. As a result, we've developed software algorithms and deployed over-the-air electric bus analytics that help us improve our designs more rapidly, and transit agencies improve their energy use and driver performance using information from systems such as our Connect 360 analytics. Finally, we must also provide full turnkey infrastructure solutions to support the electrification of your fleet, from planning for route and energy optimization to charger installation, and finally commissioning. Essentially, a one-stop shop for all project management and logistics. So where's New Flyer going with cutting-edge electric bus and charging systems in 2020 and beyond? We will continue to tackle a complete and diverse range of smart mobility projects to solve the challenges of the smart city. We believe in a broad, low-carbon propulsion offering and diverse solutions for the complex needs of a very wide range of transit agencies. Many projects are further along, such as the Smart Rider system, using sophisticated chassis control and a fully electric wheelchair ramp. It allows for a much more efficient and easy entry for all passengers. Some projects are still trials at this point in time, such as our efforts with automated vehicles and robotic research. However, we have some very exciting milestones within reach in 2020. Unfortunately, there's more than I can speak to here and more than I can list. Nevertheless, we have a strong vision, a balanced approach, and a plan we're very excited about. At New Flyer, we've always been very proud to move people across North America, and we believe smart mobility is the way of the future. Thank you very much.
And thanks for figuring out the 2-second delay. And so I'll leave it to the rest of you to navigate that 2-second delay. With that, I'm going to introduce John Walsh from Proterra. And we were just having a chit-chat yesterday about the history of electric busing. You've got New Flyer, Nova Bus, Gillig, historically bus makers, or metal benders, as people used to say, that are trying to package electric powertrains underneath a bus that they've made for many years. And then you have BYD and Proterra that are battery electric energy storage makers that are trying to package a bus around an energy storage solution. Two very different pathways, and they're starting to converge. And so with that, John Walsh at Proterra.
So it's here? Okay, I did it on something.
I'm just going to ask, if we don't mind from the AV folks, where is the receptacle in the room? Oh, it's right there, so point at him. Yeah.
All right. Thank you. My name is John Walsh. I'm the Senior Vice President of Proterra, and I've been in the industry for 30 years, all on the supply side, mainly fossil fuel buses. And I want to take you back to Paul's slide that he had up earlier on climate change. I got into this business 30 years ago to sell buses. 8 months ago, I joined Proterra. So I'm very new. If you ask me a hard question, I probably don't have the answer, but I'll get it for you. But one of the pictures that Paul had up there was the state of Florida and a huge hurricane coming at it. And that particular hurricane, Irma, took my home out in St. Augustine, Florida. So climate change is real. And it's not just one hurricane, it's Michael, it's Matthew, it's Irma, and Dorian just came through. So I'm glad to be in this industry. It's an important part of what we do in transportation, and it's affected me personally in my story. So that's my story. So let me tell you Proterra's story. This is a 10-year conversation. Sorry, I'm going to have to take you back to 2004. We started with a grant from the US DOT to manufacture a hydrogen fuel cell bus. And so we were the very first company to ever build a hydrogen fuel cell bus, and we did. That bus today has been donated to the Transit Museum in Pennsylvania. And as we went along and looked at how we scale that technology, we thought, it's not going to scale. It's too expensive. We don't think it's going to scale. We're going to go down the battery electric path, and that's what we've done at Proterra. So we started in 2004. Today, we're in 3 manufacturing facilities, over 400 employees, and guess what? It's no longer a science project. We have 105 customers with 56 deployments in 56 cities. So it's no longer a pilot. It's becoming reality. We have 9.5 million service miles out there, and we have a lot of dedicated employees that have come from different parts of the industry: transit, automotive, and battery. Yes, we're based in San Francisco, and we do have a lot of employees from Tesla. I'll tell you, it was tough working for Elon, I guess. I don't know. But we're proud of our facility in Burlingame. You should come visit us at any time. We manufacture our own batteries. We do not outsource those at all. We make them robotically in our facility in Burlingame. We have a bus assembly plant in Los Angeles and a bus assembly plant in Greenville, South Carolina, right next to BMW. So what happened? In 2004, we built that first bus, and it was $1.2 million. Today, our bus starts out in the low 700s. So we've reduced the price $500,000 in a matter of 15 years. We started manufacturing buses in 2011, and today, if I can get it to go, you'll see that many, many cities are adopting electric buses. So there are mandates out there. I agree with everything Paul said around these mandates. You can't get there quickly, and you should take your time as a property in doing so. California is probably the largest with their mandate, but New York City, Washington, D.C., Chicago, there's a lot of mandates out there, and some that are also coming to Canada. So as you see the curve, what we believe will happen is fossil fuels will go this way, battery electric will go up. Our customers, yes, there's some dots in Canada. So we have deployments right now in Toronto, Edmonton, and in Banff. We're very proud of that, but we're now over 100 customers, 800 buses in 41 states and provinces. We're very, very pleased with our progress, and there's a whole lot more to come. So our bus. Thanks for that intro. You did a great job. So what have we done? We built batteries. We positioned them underneath the bus, which we believe that's where they belong, and we built a bus around it with a high-voltage system and a process that works very, very well. Our bus is made of all composite. Why? It's strong and it's light, and that's what you need in a battery electric bus. We don't believe in the word agnostic. We don't think you can take a platform and convert it. We believe you have to be purpose-built, starting from the ground up, and that's what we've done at Proterra. We have a single-drive motor. We also have a dual-drive motor. So there's a motor on each wheel, which gives us 510 horsepower, but also gives us double the regeneration for the battery packs. In addition to that, we have adopted the universal charger of 1772 for plug-in charging and 3105 for overhead charging. And we're really pleased with that. It's got to go. Our batteries. This one's going to go a little slow. So we start out with a lithium-ion cell. This is one of those that kind of goes. Then we build into what we call a brick, a block, and a module. And in our battery packs, there's 1,500 modules. And this whole assembly process takes place in Burlingame. So we're proud of these batteries. One thing I will tell you about battery technology, it is improving. And next year, we're coming out with a new cell that will give us even more range than we have today. So we're very pleased with the technology and where it's headed and where we're going. One thing we do at Proterra that we would like to emphasize is testing and safety with our batteries. We think it's very, very important. And this is just some bullet points on thermal runaway, the type of testing that we do, intrusion. We're really proud of what we've accomplished with these packs. This picture I love because I get the question all the time, what are you going to do with these batteries after the bus has expired in 12 years? Well, our battery packs are 98% recyclable. That's important to note, but they're also stackable. So we can stack 9 batteries on top of each other and create a megawatt that we could put at a depot for storage. So our engineers have thought of everything moving forward. Range. I'm going to answer the question just like Paul did on range. I have no idea what the range is at your transit property. We have to come there, and we have a service to do route simulations for you to tell you what the range is in Edmonton, or what the range is in Quebec, or what it is in Vancouver, because it's different in every city. If you've seen one transit authority, you've seen one transit authority. They all act differently. So we have models that we come out and do range. Our packages for batteries are 220 kilowatt, 440, and 660, which is a lot of energy on the bus. Our charging, again, we do overhead and we do plug-in. And I like this bullet at the bottom because even though we have our competitors on our slides, we want you to universally accept battery electric buses and charging. So with our chargers, you can charge Gillig, New Flyer, and Proterra, and you can charge any car except a Tesla, but they do have an adapter. So with the infrastructure that we have, we've now come up with Proterra Energy, which is a brand new company. We make our own charging systems at Proterra, but we also partner with companies in the industry as well. So we have a 60 kilowatt, a 125, and a 500. We also have a multi-dispenser as well. And we're just showing you a couple of our deployments that we've had. 105 customers, 56 deployments so far. We have Apex, which is our telematics system. So again, not just having the bus, the battery, and the chargers, we need communication amongst all of those items, and we have that with Apex. This is what a deployment would look like on a large fleet, and we have models to do that currently today. And this is our process that we go through when we engage with a customer. So we've talked about route modeling. Here's an example at RTD, and I'm sure you'll send these out. I'm trying to go quick. We do battery leasing. I've got a session on that at 4:30 today about financing buses and batteries. And I'll leave you with one last slide. Our technology is so good, we don't manufacture every bus, so we don't make school buses or over-the-road coaches, but we're now selling our technology to Daimler for their Thomas school buses and to Van Hool for their over-the-road coach. So we do outsourcing on our technology. Thank you. Look forward to your questions.
Thank you so much, John, and for managing this clicker as you did. And you took the words out of my mouth because for 4 years we've been hearing, but can't we use 1 kilowatt hour per kilometer, 1.2 kilowatt hours per kilometer, 1.5? No, you can't. You just can't. And in some jurisdictions, it's 4 kilowatt hours per kilometer. In some, going downhill with an empty bus, it's 0.5 kilowatt hours per kilometer. So there is no such thing as range on a bus. So thank you so much, John. And with that, we're going to turn to Ray Little, VP of Sales at Nova Bus. And Ray's just got oodles of experience and is well known to the CUDA community for his years of industry experience in transit. Ray.
Thanks, Josipa. Good morning, everyone. It's great to be here with you. Do you have control of the slide deck at the back? Okay. I'm going to ask you to advance the slides, okay? All right, thanks. Guys, I'm excited to be here to talk about electric buses. I'm also excited to be able to get my first 5 minutes of YouTube fame. I think my kids will actually be impressed with me now, so. Guys, we are going to dive into electric buses. Next slide, please. But first, we have a small message from my sponsor. Nova Bus is actually owned by the Volvo Group. Next slide, please. And some of the brands that you might recognize from Volvo are not just Volvo trucks and buses, but also Mack trucks here in Canada and the United States, as well as Volvo Penta engines. And of course, bringing it closer to home, next slide, please. Nova Bus is part of the Volvo brand, and we're here, of course, today to talk about Nova Bus electric buses. Thanks to CUTRIC, we have several electric buses out on the streets under that program, and many of you will know that we have electric buses operating about 18 hours a day in the city of Montreal. But this slide here, it's important, I think, for us to pause for a moment and talk a little bit about the European experience with respect to electric buses. In Europe, generally speaking, they talk about PHEVs and 100% electric vehicles synonymously. They don't draw a difference. And it's led to a large proliferation of PHEVs deployed in Europe, and in the case of Volvo, we have about 400 of them, along with about 100 things called OpCharge. It's the J3105 solution, and I'm going to talk a little bit about OpCharge later. Next slide, please. At Novabus, our approach was to electrify our current platform to make a 100% electric bus. There's a bunch of benefits to what we call the LFS bus, but really that vehicle has become known as the industry workhorse. And like I said, we've electrified it. Next slide, please. One more slide. Thanks. Like many of the people on the stage, we have had a long path to electrification. It began with us electrifying components on a diesel bus. And of course, then we became leaders in the diesel-electric hybrid bus business, and that's led us to where we are as a 100% electric bus on the street. Next slide. It's important to go back to our hybrid experience for just a moment. We began introducing, many of us began introducing high voltage components on buses many years ago. And for Novabus, our approach to the market was to develop high voltage training programs, maintenance programs. We're using many of the same hybrid components on our electric bus today. And this is to deliver reliability over your 12-year or maybe 15-year service history. Next slide. This is just a quick snapshot of some of the Novabus hybrid projects. We have very deep experience and are leaders in the hybrid bus business. It ranges from stop-start technology all the way through to a thing called geofencing. And for those of you that don't know about geofencing, I'd invite you to ask me questions after the session. But in a nutshell, you can get approximately 25% engine off time by geofencing your cities. Next slide, please. So I would like to spend a little bit of time talking about OpCharge. This is also known in the industry as J3105. The reason that OpCharge is critical, I think, really stems around two primary points. It's around, first, the operation of lithium-ion batteries, and second will be the slide that I cover next. And so with respect to the operation of lithium-ion batteries, I think we all know that they come with a warranty, and there's some fine print in that warranty. So we are not allowed as an industry to charge lithium-ion batteries above a certain percentage or discharge them below a certain percentage. And generally speaking, as a rule of thumb, we have about 75% of that lithium-ion battery's capacity as usable. So this is why the conversation around range can be so difficult. In addition, most lithium-ion batteries decline at a fairly steady state over the course of 6 years. So given the average transit duty cycle, at the 6-year point, we're left with 80% of the battery's usable capacity. So illustrating this as an example, and I hope I don't lose you here, I hope I don't bore you with these numbers, I'm an accountant by trade, but if we take an example of 450 kilowatt hours of battery on the nameplate of a bus, and we go through that math of 75% of it usable, 80% available at year 6, and I had to write this down, it comes out to about 270 kilowatt hours of usable energy on the bus. And then if we take the Altoona test reports where they're talking about 2.2 kilowatt hours per mile to propel the bus and its components, we come out to a range at year 6 of about 120 miles or 190 kilometers. So this is why we think the OpCharge is a critical part of the long-range bus conversation. And like Paul and John, we're still not heating the bus or cooling the bus using those numbers. So it leads me to the second reason OpCharge is important. Next slide, please. What we're showing, sorry, one more slide. Thanks. What we're trying to show here is what we're calling a smart charging garage. And you can see inside that illustration there that we have a pantograph illustrated above the bus. And the concept here is that the pantograph, the J3105 connection, would move in a gantry style from bus to bus. This system would be integrated to your CAD AVL system, as well as your wayside energy management system, where we're controlling how much energy is delivered to each bus based on tomorrow's duty cycle. We're also trying to peak shave, and there's many other advantages to taking this approach. It wouldn't necessarily be a high speed or a slow charge. It's how the energy would get delivered to the bus. And with this concept, where this leads us is to the buses being attached to the grid when they enter the depot. And this also leads us to the opportunity to provide automation or autonomous operation at the depot where the bus goes through that maintenance cycle while it's connected to the grid, while it's pre-climating for the next day's work. So with that, I'd like to leave you with that. My 5 minutes of YouTube fame is up, and I really appreciate your attention today. Thank you.
That's great. And moving on now to the charging side of the equation, I'd like to invite Alex Lalonde from ABB, with whom we've worked in recent years on the Pan-Canadian Electric Bus project as well, on the very challenging side of the charging infrastructure integration. Alex.
Thank you very much. Okay. So, well, good morning, everyone. Alexandre Lalonde here from ABB, product manager for the e-bus and e-truck charging solutions in North America. Why North America and not just a global role? So there's a global person responsible for the same product line as me on the global level, but we understood fairly recently, I mean about a year ago, that North America had its own requirements and own beliefs, own opinions that would require a very specific approach, I would say, in terms of product offering. So that's why my role came in. I'm originally an electrical engineer as well, specialized in power system, so I know a little bit about power. I'm kind of a young kid here on the panel, but I think from the past 2 years I've been involved on many discussions, many challenges as well on projects. I'm trying to shift slides. Okay, but I mean the experience that I've gathered over the past 2 years, standing on the J3105 Standard Committee as well as talking to pretty much all the OEMs across North America, I can give you quite a good overview of what was in the past, what's currently the norm, and what's coming next. Just to give you a quick overview of what's ABB and strictly on the EV charging field, because I think globally ABB, if for the folks in the room that don't know ABB, it's a very global company, about 140,000 people worldwide. So really a big player in the power system and energy markets. On the EV charging side, ABB has been in the EV charging side since 2010, acquired a startup company called Epion that did basically the first DC fast charger that was installed in the field in Europe. That's going to be on my next slide. So up to today, we have installed 11,000 DC fast chargers across the world, and on 800 of them are high-power charging stations between 150 to 450 kilowatt chargers. So a lot of experience, a lot of projects that we did globally that basically gather all the experience under the same roof, and that we can basically offer to our customer. So chargers in 70 countries. I inspired myself to build this presentation. It's going to be quick. Oh, I see 3 minutes. We basically, where we come from the start of Epion. We started, putting in the field one DC fast charger that had no standard. So we had our own proprietary connector that was used to charge a vehicle. So that's where we come from. So we know the struggle of having no standard and no interoperability in the market. But we've been part of the first groups to basically start a standardization with the CHAdeMO in 2010, and then in 2012 the CCS effort came in Europe. So we've been since the beginning part of those group, and nowadays, so my role is also to stand and to be part of the North American standard organizations, but we're a strong proponents. We like and we push for standardization across the organization, like all my colleagues here on the stage mentioned in their presentation. Where we are now in terms of product offering, so if you've seen ABB's presentation like this 2 years ago, you would have realized that we had much fewer, I would say maybe about 2 products. Now we very much diversified the offering because we understood that pretty much all the transit properties or even the customers buying electric vehicles have different needs. So we came up with a very good range, I think, of different power levels and different architectures of products to fill and to fulfill, hopefully, all the needs of our customers. You can see on the screen here, we range from 24 kilowatt wall-mounted units to the pantograph systems that can do up to 600 kilowatt and passing through the depot charging solution with multi-dispenser concept. Where we are going, so we all know, I think, that right now and the past few years, we went into pilots, right? 2, 5, 10 buses at a time. So our product offering was also aligned on this to offer a very flexible and very straightforward charging solution to be easily installed in a transit property and not require a lot of big changes in the electrical grid. Now, where we're going is full-scale adoption. So full-scale adoption means a lot of chargers in a single location, on-route charger in a technology mix. So why on my slide I'm saying technology mix is that 2 years ago we were talking about depot charging versus opportunity charging. Now what people are talking about is using opportunity chargers to charge in depot, so using pantograph in depots, using depot chargers for the base load, so charging overnight, but then using opportunity charging to top off the batteries as you go for long-range buses. So, I mean, just the general concept of opportunity charging versus depot charging, I think is in the past. What the discussions right now are really, how do you integrate everything together in a very intelligent and smart manner to make the most out of your assets, basically. So that's what I call the technology mix. And obviously, smart charging and fleet management, it's all just on top of what interface you're using and you're selecting. That's the golden question. But just integrate, I think we all agree that integrating everything together is the solution moving forward. My last slide, let me see if I can. So the last slide is just to give you an overview of what are the stakeholders and what we need to integrate together to make this fleet and all this electric bus fleet happen is really the grid side, the charger management, and the fleet operation. So everything has to be integrated together, and we should stop thinking that you can integrate electric buses in your fleet the same way that you can, and operate them the same way you do for diesel buses. That's too often what I hear from customers, and I think we need to stop that and evolve, in the future. I know we're running out of time. Hopefully we can answer more questions on the panel. Thank you.
And so actually, Alex, that was a great segue because we heard that talk about range is an old discussion. You know, if you're at the cutting edge, you don't really talk about range anymore in kilowatt hours per kilometer per bus. You talk about systems. And as Alex mentioned, dialogues about is it in depot or en route? That's an old discussion. It kind of dates you. That's in the past, and we're beyond that. And as we'll discuss on this panel, is it electric bus or hydrogen? It's an old discussion. We're over that. So there's these older discussions, but if you haven't had those discussions at your system, it means that you're facing a lot of the dialogues that over the last 5 years, in many cases, these organizations have responses to and solutions for. So with that, we're going to turn to our final speaker, Brian Pollock from Siemens, another great partner on the charging side for our Pan-Canadian Electric Bus project. Welcome, Brian.
Well, first, thank you to QTRIC for asking Siemens to participate on this panel discussion. I am responsible for business development activities on the e-bus topic specific to DC charging and transit. So a little bit about Siemens first. We're a over 170-year-old company, over 90 billion euro sales annually. We're present over 190 countries globally, but only one country is important today, right? That's where we're at today. Which button was at the top?
Yeah, there it is. And I'm
There
just
it
going
is.
to check here if your delay is over. Yeah. So if you point there, it's only about 2-second delay.
Okay, great, thank you. So this spider web does a pretty good job, I think, of illustrating many of the challenges that transit agencies face as they consider electrification of a fleet. You've got a lot of considerations on the power side. Can the utility even provide the power you need? I can tell you that there's some transit agencies today in the US who are experiencing the fact that no, the utility can't provide this power for a period of maybe 3 to 5 years. So one of the very first things a transit agency should think about in the planning process is, where am I going to get this 5 to potentially 15 megawatts of service interconnect to supply this depot of 100 to 200 buses we may be building out? You move now from a continuous dependency on a fuel supply to a continuous dependency on power. And you also, as you deploy all these different chargers, these are switched mode power supplies. You also have to take into consideration what harmonic content you might be reflecting to your utility provider. Then for charging operations, you have to have space to mount all this equipment. So does the facility have the space for all this charging hardware? How are you going to manage the charging operations? How are you going to optimize the use so that you can minimize the amount of power you consume at any one time, minimize demand charges? On the commercial operations side, you have shifting costs from fuel now to electricity. What does that look like? Hopefully it represents a savings for the transit agency. And then on the maintenance and service side, now you've got the need to manage high voltage systems, whereas previously maybe you were managing, you're servicing lighting and HVAC loads inside of office spaces. This slide does a good job of illustrating just some of the different technologies that are available. So at Siemens, I don't have a slide today that illustrates the portfolio of chargers that we offer, but we have a complete solution from plug to grid. Whether it's a level 2 AC charger for a passenger vehicle, a DC fast charge product for charging a light duty or passenger vehicle in a corridor, or our high power DC charging solutions for depot applications. We also supply all the various infrastructure, or what's called make-ready product in this space, all the transformers, switchboards, switchgear that's necessary to deploy power from the grid to the plug of the vehicle. This slide also illustrates some of the different options you have to consider when looking at a full-scale deployment. We can do the plug-in charging, we can do en route charging with a pantograph, or we can do in-depot charging with a pantograph. The advantage of pantograph charging is it removes a person from the charging process because it's an automated procedure. Other things to consider when you're talking about a full-scale deployment is where is that energy going to come from on a continuous basis? Are you relying on the utility to never have interrupted power? Or if you lose power for a day, then what? Are you going to deploy a microgrid? Are you going to deploy co-located stationary battery energy storage so that you can minimize the demand and time shift when the energy consumption is required to charge the vehicles? So there's been a little discussion today about the J3105 standard. So there's a couple iterations of that. Primarily in North America, we're seeing the J3105 deployment, which is the structure down to the bus with the rail system on the bus. The nice thing about that approach is it's fully automated. The bus driver pulls up if he's positioned correctly and sets the parking brake, then the charging process begins. We are looking at projects where we're going to allow not only for that pantograph to be mounted on the ceiling in a depot, but for multiple pantographs to be mounted to a common charger and then sequentially charge vehicles in depot as they're parked in an overnight scenario. The other picture up there shows the J3105-2 implementation, which is the bus up pantograph deployment. Not as common, not really seeing that in the U.S. Most of the bus manufacturers up here today are doing the 3105-1. And then I'm not showing the 3105-3 because I've only seen that in a cartoon. So from a commercial standpoint, this is what Siemens is offering in terms of overhead chargers today. We have a 300, a 450, and a 600 kW version available. And, you know, we comply with the OpCharge standard. When 3105 is available, we're going to comply with that standard. For back-end communications, we'll comply with OCPP so that if you want to use our back-end for monitoring this asset, you can. But if you don't want to, whoever's OCPP back-end software will function. We've got a couple different style masts. I think this picture is showing pretty much the architectural design style mast in both cases. I think the next slide shows the industrial style. And then I've got a picture there too of a deployment in a depot with it mounted to the ceiling structure. This slide just shows you some of the different components that make up an overhead charger. Deploying an overhead charger is not something for the faint of heart. It's a major project. You've got a significant civil works that needs to occur because you've got underground duct banks that need to go between your power section and your mast. And you know, you're digging down into the ground probably 5 to 8 feet to bury those conduits and put that mast foundation in place. And there's some transit agencies that go through this deployment and figure out, oh, there's a gas line right where I wanted to set my mast. Surprise you shouldn't have to encounter during a deployment, but just planning. Planning is important when deploying these overhead structures. I'm not going to spend any time on this slide. It'll be available for you to look at, but just a lot of different considerations to take into account when doing an overhead deployment. This slide just shows a couple examples of where we've deployed overhead masts with pantograph, and then just the different OEMs and where we're at in stages of interoperability. You know, thanks to Qtrich, we had the opportunity to have ABB chargers and Siemens chargers tested with Nova Bus and with New Flyer products. You know, BYD, we're doing a deployment in LA, and they will have a bus that'll charge at one of our overhead chargers. Proterra, we're talking to about interoperability testing, but talking about the components they use and what we've had success with in the past, there's no reason why it shouldn't work, you know, after a day or two of just testing it out. Siemens also makes a depot charger. It's a 150 kilowatt unit that has power section and then up to 4 remote dispensers. And just like the overhead charger, it's OCPP compliant for the back end and J1772 compliant for the plug in the front end. And then in interest of time, I'm going to keep moving here. This slide illustrates where the different bus manufacturers line up with their voltage ranges and where their batteries charge. For the most part, everybody's in the same range, that 400 to 800 volt charging range. BYD has a product that charges at a little higher voltage, and one of the reasons why we also have a new voltage range for our second generation of product that we're going to make available. Proterra in the past was using a lower voltage range, but as I understand, next year you're going to be delivering vehicles with the higher voltage range, more compatible with the other vehicles. So something to keep in mind. I mean, your passenger vehicles charge down in this 200 to 400 volt range. If you're buying a charger and you're intending to use it to charge a passenger vehicle and it only delivers 500 to 800 volts, it's not going to put an ounce of energy in that car. And then the last slide, real quick. Siemens is offering a software as a service for depot management. It's going to have a couple aspects to it, monitoring and reporting, energy optimization so that we analyze when vehicles come in, when they need to be charged, how you might time shift that usage so that you can minimize the demand requirements from the utility. And we're also going to have a piece that will manage co-located energy storage, so a bit of a microgrid control. And then this will also allow us to monitor the overhead chargers, and then if you have a cluster of overhead chargers, do some demand management on those as well. And you can see there's a lot of hooks into other systems. We're going to have APIs available for pulling data from the OEM cloud so that not only do we have the history when we're trying to optimize the system, but we'll know when that bus is coming back in what it might need for that overnight charge to be ready to go the next day. So I can see I'm getting the hook here, so that's it from my side. Thank you.
Thank Okay, so slowly we're figuring this out. And the deep irony is if you were at our hydrogen fuel cell conference in June in Mississauga, we went to this hotel and it was a great event hotel, but we showed up and we realized it was a wedding event hotel. And so the AV really didn't work out. So we thought we're going to go to a pro hotel and doing a pro job, but it looks like the problem is on our end, everybody figuring out this clicker. So for panelists coming up, if we can help this pro hotel help us at Qtrig be a little bit more pro, we'd really appreciate that. So with that, we've got just a great overview of the technologies, where we've come from and where we're going. Some of the older debates in terms of range, depot versus en route, hydrogen versus electric, another one that's going to come up later on in panels. These are sort of the older debates, and now there's a lot newer debates that are accruing and that transit agencies are facing. And Brian, I'd note that you had a photo of the Vancouver bus there that was part of the Pan-Canadian Electric Bus Project, but you had the old wrap, and we've got colleagues here from TransLink, and if you've seen the new wrap, these are the most beautiful buses I've ever seen in my life. They've got this wrap that's got glow-in-the-dark imagery on it, and the chargers glow in the dark. It's amazing. You got to go out and ride on these beautiful buses. So with that, we're going to segue into some of the upcoming things. And we're going to ask our panelists, each of you have a microphone, and I think yours is there, Kirk. We're just going to do a quick, if you want to check that it is turned on. We're going to use our parliamentary rules of behavior since we are in the context of a federal election. So we're going to ask for 60-second answers from panelists. And the first question that we want to ask panelists is, it's going to put you in a difficult position. You never want to ask OEMs, who is your favorite client? But that's what we're about to ask you. So of all the transit agencies that you've worked with or seen in North America, which transit agency would you say is an exemplar for moving forward with electrification, and why? What is really so great about this transit agency that others should maybe pay attention to and even try to model or mimic? And with that, we'll start with you, Kirk.
Okay, I'll start off. Thank you very much. It's really hard to say. Actually, I've been very impressed with several transit agencies, and what we're always looking for is partnerships. So I think what we're looking for ideally, and I think the right mindset is you're willing to accept the challenges that are going to come with new technology. And I think unfortunately what I've learned over my last 10 years, there's a lot of transit agencies that are all about risk mitigation, and it's very much just about risk mitigation. But when you're talking infrastructure and new technologies, you have to be willing to take that challenge on and know that you're going to work through the risk and work through the challenges. So examples that I've seen would be STL or STM. It would be TTC, and it would be TransLink as some of the bigger agencies that we've worked very closely with. But I think it's that willingness to accept the challenge and leave some of the risk mitigation behind, because we're going to work through that together. And if you want to avoid all risk, then you should just wait, probably.
And
you.
we've heard that in terms of procurements. If we're constantly going for the lowest possible cost in a public tender, you're not going to get to electric, largely because the costs accrue through operations, not in upfront capital. So that risk profile being a leadership quality. All right, we're going to turn to our next panelist, and we'll go down the line from left to right from Kirk. So John?
Really, can you hear me okay? Really hard question. We have a lot of customers, and I could take you back to the beginning of time with Foothill, who was our very first customer in California, doing fast charging, to Tallahassee, to Via in San Antonio, and then Worcester in Massachusetts. And really the beginning of time was fast charging, and now we've gone to extended range batteries. So the model has really changed. And the conversation is, how do we get a 1-to-1 ratio diesel to electric? And that's really the goal. So not because we're sitting here in Canada, like I said, we have several customers, but Edmonton, who is just getting ready to deploy, has done an outstanding job of planning. They have a huge staff. They're doing multiple things in depots. They planned this out with telematics. It is truly impressive. The other point I'll make is when we get a pilot of 1 to 2 buses, I agree. I don't think that customer is very concerned about going with a full deployment. I think they're just testing it and really not wanting to take it much further. I applaud Toronto at TTC for doing a large pilot with multiple manufacturers. Many of us are there with pilots, and that's the right way to do it. They're testing different chargers and different buses, and that's the way you should do it to figure out what the path is forward.
Fantastic. Thanks so much, John. So if we're going to do a pilot, it ought to be big and large and meaningful. And if we're going to do a deployment, it ought to be for full-scale integration objectives. All right, great. And Rail?
Hey, thanks, Josipa. I am going to give a list of the top 5 at some point, but really what I wanted to talk about is what these top 5 have in common. And it begins with funding. It begins with money. The top 5 I have on my list have money. They've also taken, for me, quite a scientific change management approach to introducing electric buses. And what I mean by that is they have a series of champions, and those champions are supported by a project management structure. So I think that's critical in rolling out electric buses. They also have a close working relationship with their power authority, so I think that's advice that I think these top 5 would share. In my mind, Seattle is ahead of the other 4, Toronto, Chicago, New York, Montreal. But I need to give a special shout out to the small transit authorities that are literally implementing electric buses through passion. And of course to QTRIC for some of the work that you have done. I don't think these people can be leaders in their functions without QTRIC here in Canada, so well done.
Thank you. Well, we'll take it. Thanks so much. And Alex at ABB?
Yeah, I would piggyback from Kirk's and John list, basically. So TTC, I think, is one of the great one, just going with multiple manufacturers to test the technology and compare them one to one is, I think, a great idea. I would say TriMet in Portland, Oregon, just by using depot charger and on-route charger on the same bus route, basically with the same buses. So really looking at how to implement and optimizing the technology mix. As well as Edmonton, obviously, for the creativity of using on-route chargers in depots, well, just pantograph chargers in depots, and large-scale deployment and going full speed with 30 buses and even more moving forward. So that's very good, I think.
That's fantastic. So the in-depot overhead charging movement in order to support the large-scale electrification, quite innovative. And a couple of you mentioned Edmonton Transit, a really great project management team moving the project forward.
Yeah, it's
Great.
a technology shift. It's
Absolutely. And culture shift
Pushing
at that
the
transit
technology.
agency.
Yep.
Brad?
Yes, so I've been on this topic for about a year now, and my answer is going to come from a perspective of my base in the United States, although I support my Canadian colleagues. Most of my experience has been with the U.S. deployments. Because of the decision of the Air Resource Board in California, LA Metro and the political environment in LA, they want to deploy full fleet electrification by 2030. I have no idea how they're going to get there, but they're embracing it, and they're going to figure out a way to at least get most of the way there by that time frame. So from that perspective, they're kind of leading the way. But then on the other side of the coin, New York City Transit, the largest bus fleet in North America, and they are crawling. But it's because they're looking at this from every aspect so that when they're done analyzing everything, they can go full scale quickly.
Mm-hmm. So systems planning and integration, and then political leadership on the West Coast, motivating the industry. So we're going to turn to the audience for questions, and in a moment, and just to remind you, there are 2 mics, so we'll ask you to line up if you've got your questions ready. But with that, what we've got from our panelists here is there's a lot of innovative systems. Seems that if we boiled through them and distilled to the top, what is probably common is either there's political mandate, forcing them to go that way, or there's money on the table. And you can't do what TTC did without cash on the table, and you can't even do what Brampton, New York Region, and TransLink did with our project unless there was cash on the table. Edmonton had cash on the table from an NDP government that was very supportive, and a federal government. So cash has got to be on the table, and without the cash, you can't be as innovative. And that leaves the open question of what about all the rest of the transit agencies, the mid-sized ones, the ones that don't have that amount of cash municipally or even federally or provincially. And we're going to come back to that in a moment, but we have a question here from Doug at IBI.
Hi. So in support of the idea of large-scale systems integration that's vendor agnostic, on the charger side, there was talk about OCPP that would support that. So I guess I'd be interested to hear from the bus manufacturers about something analogous in terms of flexible API that they might be offering for that purpose.
Okay, so moving into the dialogue about flexible APIs, which one, we'll start over there actually. Why don't we force tell this?
Yeah, so from our side, with our software as a service, we're going to have an API available for connectivity to whoever's OEM cloud the transit agency needs connectivity to. And we don't need all the bus data. We just need some of the bus data to make it relevant for charging operations.
And in fact, I'm remiss because we should make sure that everybody understands what API actually means in the audience. And so maybe just by show of hands, who understands what the concept of an API is? So we've got maybe about 50% of the audience, right? It is a concept, it is an acronym, it's a bit cliche these days, but it refers to a technical concept. And just to put it basically, there's a unit, there's a bus, there's a vehicle, there's a something, your watch on your hand, and there's a computing system somewhere controlling how that thing works. And that unit has to talk to that control system, and there's going to be some kind of communication between that unit and that control system. And the decision maker in between, whether it's a device or a software, is the API. And so if all of these devices, these buses, these shuttles, these autonomous cars have different API standards, or they don't have a common API, then they can't talk to the same control system on the back end. And so just like we talk about interoperable charging systems, if the software and the brain control do not talk to each other, the system breaks down. And so the question was really about the movement towards these API standards, commonality, and what does that mean for the future. We faced it in our own project where not all buses necessarily on day one were able to talk to all loggers and all software systems. So Alex.
What I would say, the question is much more towards the bus OEM, so I'll let them some time. But I think on the charger side with OCPP, we kind of solved this issue by a standard common protocol to integrate all charging infrastructure. But now what I see coming more and more is in the bus environment and the transit environment, it's much more industrial type of communication protocol that are being requested. So we may see in the future some sort of standardized exchange table on a more industrial type of communication protocol, like OPC UA, something like that, that would be shared between the vendors, that could fit more into this industrial environment versus OCPP, which is more targeting the car charger market. So that's also a trend in the near future.
Okay, so if we globalize the question more towards a commonality of APIs and software controls as well, Ray?
Thanks, Josip. But just a quick check. I was wondering if the consultants are paying us for this. Guys, you saw my slide where we envision a smart charging depot. So we've already assumed that we're going to be sharing APIs. I would say on one technical note that those APIs may be unique to each transit authority. And where I'm going with that is each of you have your own CAD AVL system, and I think we all know the challenges of APIs among that network. So doing it across the entire country or the United States and Canada, I do see as a challenge, but I don't see it as much of a challenge on a customer by customer specific basis. Does that answer the question?
So you think transit agencies can get away with maybe even having unique APIs per jurisdiction?
Yeah, I would see that as at least a starting point. Yeah.
Okay, and interestingly enough, and we'll hear about it a little bit from our smart vehicle panels, I mean, Los Angeles launched its own city-led API for autonomous shuttles. And of course, if you're an automaker, an autonomous vehicle maker, you now have to design your vehicle system to plug into that software communications protocol.
And I would just clarify then to my original question, I wasn't necessarily talking about something that would be the same protocol as is the case with OCPP. Like for integration work that we do, it actually can be fine if each of the different things that you're integrating has a different API as long as it would be maintained over time. Yeah.
And so there's some support for that view, but on the flip side, folks have said, look, not all of us can be LA. LA can move the audience, LA can move the market, and if everybody has these unique circumstances, it's going to be really hard for the software providers and the manufacturers to bring the price point down as far as possible. So that is one of the counter-arguments that cities need to get together and have very common APIs and also very common software and communications protocols across the vehicle charging and overall systems network. The jury's out.
Yeah, so I think you guys can see the strategy at Proterra is to be fully integrated bus, battery, charging, and telematics. And so we have TA, what we call technical assist, and we have turnkey. So we can do from the utility all the way back to the bus in one package, or we can do it a la carte, and we're doing that right now. So it can work either way. It just depends on the property and what they're what their goals are for the fleet. But we can do it either way, and you'll hear that term TA and TK with us pretty often, and that's kind of what that acronym stands for with us.
Okay, great. And Kirk?
Yeah, I would agree with what John's saying. I mean, we can do it either way. I mean, we've been very agnostic and diverse in our approaches to customize. Transit agencies are also different. And we took a lead role with interoperability standards at a charging level. So if we have to take that up a notch to a communication protocol or to another level to allow full integration, yeah, we'd be very open to that. And we've taken a lead role, and we would look forward to having conversations on that. So.
Fantastic. So a real divergence in what's possible, but a lot of opportunity here in terms of unique solutions or common ones. Michael?
Thanks, Joseph. A fantastic start. One of you, I think it was Kirk, mentioned in-motion charging. I'm just curious as to what you see the potential for that, especially in systems like Vancouver, Boston, San Francisco, and others that already have wires in their infrastructure, and what's going on overseas in Europe with regards to that as a potential piece of this big puzzle.
And Michael, can we just clarify, maybe there's two different types of possibilities here. You're referring to in-motion charging, where potentially the vehicle has a pantograph that comes up and connects to catenaries, and the pantograph then comes back down and maybe moves on battery, or there's also inductive charging. So were you referring to the former in terms of connecting to the catenaries,
that's right?
Yeah, and we had this dialogue because in rail, that's obviously one of the dialogues around electrifying rails, that the pantograph comes up for rail to move in and out of the garage, the pantograph comes down, and it's Hydrail for the interregional travel. Could you do that for buses too? And perhaps we'll throw in there, Michael, what about the inductive charging? Is that
Sure.
part of the future? Mobile charging that's not heavy duty equipment or using equipment that's already there. And Kirk?
We'd love to see more, to be honest with you. And I think there's a lot of transit agencies, including maybe even Winnipeg Transit, that are remorse that they took all the wires down years ago, not knowing exactly what the future was to hold. So we think there's a place for it. I mean, I highlighted in my presentation, if it wasn't obvious, about the diversity and the needs being so diverse. I think there's definitely a place for it. We'd like to do more, and we're having conversations with some of those big trolley markets now. In terms of Europe, I can't really comment on Europe very much, other than the ADL acquisition has been fantastic, and we've been talking to them on a regular basis, and between their engineers and my engineers, there's a lot of technology sharing. So if we with our in-motion charging and trolley experience can help them in Europe take more of a foothold, that's what we're doing. And between us and MCI, I tell you, the amount of energy with this technological revolution now has been just fantastic. And if that means reflecting back a few years to 1968 when the first trolleys hit the road, then you know what? I think there's a diverse place, because I don't think it's a silver bullet that's going to suit everybody. That would be my comments.
That's great. And John?
So we hear electric trolley or electric bus, but we talk in terms of battery electric bus, and there's a huge difference. So we believe that we don't do lines, but our technology could fit with anything. So we're looking at that. We are looking at inductive. We don't currently do it today, but obviously that's something that's in R&D that we are looking at, because some cities think that may be the best solution. But today we don't do wire, we don't do inductive, we do just the battery charging.
Okay, very good. So it may be part of the next 5 years to come, depending on what clients want. Okay, right?
Thanks, Josipa. Like John, we respond to demand, but you did see my slide where we do envision, at least at the depot, that the vehicle would be connected to the grid the whole time. En route, I'm more of a fan of the European approach on the plug-in hybrids and bringing it closer to home here in North America, really where we have long-range buses connecting to the OpCharge or J3105. The infrastructure around having the bus connected 100% of the time out there on your streets, I think challenges the business case on battery electric buses.
Mm-hmm. Alex?
I would say pretty much the same. I cannot really comment so much about the capabilities of buses to connect to catenary rails, but I can tell you that we've had some requests in Europe to basically build chargers that would connect to the catenary rails, because you already have the infrastructure in place on street, but you would put a OpCharge or on-route charger next to them. That has its own challenges, and I think the discussion is ongoing, but that's what's the closest to the catenary rails. And in terms of inductive charging, ABB has always been blonde on the fact that we selected conductive charging as the way forward for the next years. I we always stay open, right? We remain open to any development in the standardization. I think we're waiting very much on standardization of this technology before making a real choice if ABB goes this way or not. But I mean, that's something that the future reserves.
Okay, so there's not that many catenary lines left, but if the future brought them back, there might be the opportunity of systems integration with the charging infrastructure required for battery electric as well.
Yep.
Great. Brian?
Yeah, so first for the inductive charging question, Siemens has looked at it, but we're not pursuing it currently. Next for the question on operating a vehicle on a catenary line, Siemens Mobility does rail systems, does rail electrification, and is very much in that business today for rail electrification. The difference with a catenary line is it's a constant DC voltage, and your battery system on the bus needs a varying voltage and a controlled current. But Siemens also makes a DC to DC converter that can sit on that vehicle for charging that battery electric bus with the catenary overhead lines. But haven't seen anyone doing it here yet in North America.
So it's possible to integrate the systems, and maybe can we ask you just why have you decided not to pursue inductive charging? Is it just about the efficiencies? Because we hear this a lot. It's easy, it would be simple, but at the end of the day, it's just fundamentally not an efficient transfer of power.
Yeah, I don't really have any insight into why it wasn't pursued. Just know that it hasn't been.
All right, so another dialogue for another day, but Kirk?
Well, I can speak to that. I mean, we're looking at it as well. I mean, we're always trying to keep as much technology within our roadmap as possible. But I think there's two key things. You've touched on one with efficiencies, and if we're going to talk range and the life of a battery, then I mean, obviously, we can't take much inefficiencies. So the efficiencies have to catch up, and like we've touched on several times, all of us today, standards. Mm-hmm. I think before it can really move forward, there needs to be a lot of work on the standards so that it's easier for integrators to integrate, and it's, in the end, much better for the transit agencies to have one standard of induction to work to.
Mm-hmm. Fantastic. And for those of you who haven't seen an inductive charging system, because we do get these questions a lot, basically from the laws of physics and electromagnetism, you're sending an electron across a space of air, right? And that is where the inefficiency comes from. So you're trying to power it up from a huge power source and then basically send electrons through electromagnetic radiation across air. And the further the air is from the receptacle, the less power actually receives. In a basic science understanding, that's what you're trying to do, which is why it's a really complicated and difficult technology.
I think it's, it looks very cool when you look at it from, far away. But I think for the engineers in the room, looking at the actual system integration. So what does it take to make inductive charging happen from a system point of view? There's a lot of boxes and power conversions, losses. We talk about high frequency power conversions with high power, right? So there's a lot of things involved, and currently I think what's stopping the market on that is that if you want to work, if you want an inductive charging charger to work, you need both pieces on the bus and on the street to be from the same OEM.
Right.
So there's no interoperability so far because the standards are not there yet.
That's right. And inducing electrical movement and basically electromagnetism is from a physics standpoint, it's a really interesting kind of solution. From an empirical and practical standpoint, it is very challenging. But then again, a lot of what we heard is quite challenging. And so with that, we'll turn to Scott Gellner.
Do we have time? I know we're running tight.
Yeah, we do.
Okay, excellent. So great panel presentations, everybody. My question's more to Ray, John, and Kirk. I guess I really enjoyed Paul's keynote speech, and his pictures of the Winnipeg winters really kind of solidified a few concerns for us in Brampton. Our winters in Canada are much different than those in the States, and our council's notion for zero emission, zero carbon future is zero emission bus technology. It's not zero tailpipe emissions. So I was wondering if maybe each of you could just speak to what your current offering is around fully zero emission buses versus zero tailpipe, i.e. with diesel fired auxiliary heaters on board. Our future is no diesel. So getting there obviously has a price to pay, and Paul mentioned, I think, a number of 65% of the draw on the energy system is attributed to heating and cooling. So where are you at now, and where are you going tomorrow with your solutions?
Yeah, and maybe if you can also comment, does it make sense to just keep using diesel heaters in Canada given the trade-off?
I'm not a fan. I've never been a fan of having to keep a diesel auxiliary heater on the bus. But when it comes down to range, I mean, you're just trying to strike the best balance. I think actually for having lived several years in the Toronto area, I mean, I actually don't think the Toronto area would need a diesel aux heater. It's more for the driver than I think for the passengers who are already fully clothed anyway for the winter. They've been waiting at the bus stop. We're doing work with, we're always looking at alternatives. I mean, I would prefer to not have it at all. We're looking at heat pump technology. We have a heat pump project going now with some funding that we've received, and we're going to be working closely with New York City to look at those technologies. But again, not very good for the Edmontons and the Winnipegs of the world. Probably good for the Bramptons of the world, I would think. So that's a project that I could keep you abreast of. We're just into the infancy of it. And I would agree, we've got to look at greater efficiencies where we can run a larger kilowatt floor heater and not be so worried about the impact to range or even to the low voltage side for that matter. So I agree with you. We should eliminate it completely. And one thing that does help, I think, quite a bit, I mean, you touched on fuel cells very briefly, but if you're looking for extended range and you want to have less concerns about the energy for heating the bus, and when we look at our telematics report, we do spend a lot of energy heating and cooling buses. I think a lot of that energy has been kind of seen for free for years, and we have to get rid of that mindset. But fuel cell, as a battery charger, a zero-emission battery charger on the bus, I mean, I haven't seen enough fuel cell discussion in Canada, but it is a viable alternative. We're seeing lots of interest in the Southwest. I'd like to see more interest north of the border. We've got a 350 miles range with it, and there is energy available for heating and cooling, because what we're seeing with most properties, they're using a fraction of the energy they need. So again, there is energy for heating and cooling, and we don't have to be overly conservative with a diesel logs heater in many cases, I would say.
And that speaks back to one of the outdated debates that we've often heard. Is it electric bus or hydrogen fuel cell? And that just is a dead debate. It's both. It's both for the future. It's going to be both for a lot of systems, not all systems. It's electrification by another carrier of an electron, and it does overcome some of these issues of high speed, high range, high heat, high climate control, crush capacity, really difficult environmental conditions for electrification across all modes. John?
Yes, so at Proterra, we signed up for a test this past year with Duluth, the FTA, and NREL. And you can actually get this report on NREL's website monthly to see the performance of these buses. But those 7 buses were delivered in December of last year. And in January, if you check the weather, it was minus 60 in Duluth. We think it's the coldest place on earth. We learned a lot. Diesel, hybrid, CNGs did not run that day, but our buses did. Mind you, they didn't go very far, but they did run. I hate seeing a tailpipe on our bus. I absolutely hate it. So what are we doing at Proterra? We are now advancing from 440 kilowatts of storage to 660. That bus is at the Altoona test track right now. It'll be finished in December. In addition to that, we have a dual power with 2 motors on each wheel, which gives us double the regen, and that's going to give us even more range. What are we trying to do? We're trying to get away from that diesel fuel-fired heater if we can, and we're working with the HVAC system companies to come up with solutions. So we personally want to get rid of it, but I totally agree. You got to keep the bus warm, and you've got to keep it efficient, and that's a solution that we have today. I think we'll get there.
Thank you, John. And Ray?
And check out that test. It's an interesting read.
We'll send it out with a link to your presentation. How about that? Ray?
It's kind of nice going number 3, guys. So like Kirk, we're doing some work on heat pump. Like John, we're increasing battery size on buses. Like we showed in the presentation, we're seeing the bus being pre-climated when it's attached to the grid at the depot. So before it leaves the depot, it's headed out at temp. But I would bring us back to the math that I talked about, and I'm bringing it up again because I'm sure you went to sleep when I was talking about the math. But if we're saying 65% of the energy on a bus is devoted to heating or cooling, and I would span that to every state that touches our border and all of Canada except BC, Vancouver and Victoria, where we need to have this conversation. So the math was, I would remind you, it's 190 kilometers at year 6 with 450 kilowatts on board. And if we're using 65% of that energy, there's a new equation. So I don't see at this time getting rid of the tailpipe for heat and still having range, but the op charge is also part of that solution too. So we could deploy enough op charges to push the bus with electric heat.
Fantastic. Thank you so much, Ray. And Kirk, you have a jumping comment
Well,
there?
I mean, very good points by John and Ray. So I'm just going to jump on something Ray said here, which was an excellent point. Many of the HVAC systems and even heater systems that we design are over-designed because there is, again, in the spirit of risk mitigation, we put too much reliance within the APTA White Book specs on pull-ups and pull-downs. So the systems are designed for a very aggressive pull-down or pull-up, and you've got extra capacity there that you don't need. And we've had properties now in the Northeast asking for Houston pull-downs, and to me, that's not energy conscious. So anyway, thank you, Ray, for bringing that up.
So essentially altering the requirement on the client side to be energy conscious to be able to efficiently move into these technologies.
I think you should look at the majority of the duty cycle and look at the steady state. And yes, I know doors are opening and closing, which is a challenge, but some of those aggressive startups, pull-ups and pull-downs, which is a fraction of the time, it's not a good use of energy.
Okay, so on the parabola curve of performance, we're taking the extremities and using that as a procurement strategy. So in the last couple minutes, what we're going to do is turn to our panelists and give them the 30-second concluding comment. Unless you guys had something you really burningly needed to say on the auxiliary diesel heater, we're going to turn to our panel for final comments in 30 seconds. We're going to ask them to say, what is an old question that they used to hear transit agencies ask, and what is a new question that agencies are asking? And so we're going to start over on Brian's, and when you're coming out to these agencies or talking about electrification, what did you used to hear and what are you hearing now in terms of key questions?
Sure. I can only speak to what I hear now because I've only been doing it for a year.
True.
So, but what I hear is the concern is how are we going to scale up? Where's the power coming from? Where are we going to put all these chargers? What's the best methodology to keep charging reels up out of the way of the buses so they don't get damaged? Desire to do a lot of in-depot pantograph charging. So how they do all that, where the money comes from to get it done.
How do we scale and how do we pay for it?
I would piggyback on that, just adding that a former question is, what's the technology status? Does it work? What? Is it standardized? Is it interoperable with other OEMs? I think this is in the past, but the questions now are really, how do we scale up? How do we go full speed and fully electrified?
So nobody's asking, does it work anymore and does it interoperate? Just how do we scale up?
Exactly.
The
With
time is
pilots and pictures and announcements, I think we made this question part of history, and now it's like, are we going full speed?
Fantastic. And Ray?
Thanks, Josipa. I think 5 years ago, transit authorities, our customers, were asking us as bus builders, where is your electric bus? Is it going to get on the road? I think we've answered that question. Today, I would say that the transit authority, our customers, are having range anxiety. They're wondering where their power authority is in the electric bus conversation. And I think one of the most important things our customers are dealing with now that they didn't 5 years ago is stakeholder management. We have a lot of special interest groups influencing the operation at our transit authorities, and the lobby of your stakeholders is taking place where you're receiving a lot of pressure to move. So I think that's something that our customers are having a hard time with.
It's almost a political issue in the commercial landscape in terms of
Yeah,
stakeholder management.
Paul mentioned that during his talk too.
Very good.
We haven't mentioned much about the utilities, but the question that we've seen is, how do we afford this? And the way to do it is to get the utilities, I know there's some of you in here, to buy in. And in some cases with our deployments, the utility companies are actually purchasing the infrastructure and the chargers for the customer. So that's a good point to get to, because without them, we really can't scale this at all. So it's good to see them come on board. At APTA in Louisville this year, the rooms were busting out of the seams in the sessions that the utilities were involved in. So it's good to see them get on board, because that's what we need.
Great. And 5 years ago, I mean, the question was not where are the utilities, they just weren't anywhere.
They didn't exist.
And the question now is, where are the utilities and what's your role? And
Yeah.
chop chop. And it's a great segue to our next panel when we're going to be putting the utilities on the chop chop panel here to give them a few questions. And Kirk?
Yeah, I mean, 5-10 years ago, I think a lot of the questions weren't great questions. They were very diesel, it was coming from a diesel mindset. So the questions were very basic, very rudimentary, and that's why we felt a need to take very much an educational role. The questions now are very educated and very sharp, but I agree with a lot of what Brian and Alexandra said with infrastructure and how am I going to scale and can you help me scale? That's the big question right now, is how can we scale beyond the 5? We know the 5 work. From all the manufacturers, the 5 work. Now, how do we get to 205?
Fantastic. So where we've come from is perhaps diesel-oriented queries about will it work? What's the boogeyman in the closet? Prove it to us. We don't believe it. To fast forward where we are, how do we scale up faster than we ever thought we needed to? What's the role of the utility? And how do we manage our stakeholders from political through to the community to see that this is the way of the future? I look forward to welcoming you all back this time next year to see just how much further we've been able to accelerate this industry. With that, I'd like to thank our panel for a great introduction to technology.